Hi everyone, let's solve this problem. Missing number. Given an array nums containing n distinct numbers in the range of 0, n included, return the only number in the range that is missing from the array. So here in this case they have given us nums, and if you see it should be between 0 and n is 3 here, and 0, 1, 2, 3. These are the numbers it should be, but 2 is missing from the given array, so we have to return the answer 2. N is 3 since there are 3 numbers, so all the numbers are in the range 0, 3. 2 is missing number in the range since it does not appear in nums. So we have to solve this. So let's try to understand the solution. So first of all, we have 0, 1, 2, 3. These are the numbers, and the numbers given in the actual array are 3, 0 and 1. Yes. So now basically let's say let's first understand the XOR operation. So let's say XOR operation for, let's say, 2, binary representation of 2 is, if it is 4-bit, this is how it looks. So if I XOR, for XOR, if it is 0, 0, it is 0, 1, 1, it is 1, and if it is 0, 1 or 1, 0, it would be, sorry, this is 0, this is 1. So these are the XOR operations. So if you see here, all the bits are same. So basically XOR is nothing but if the bits are same, it will be 0. If the bits are different, then it is 1. So if you see this particular 2 XOR 2, it will definitely give me 0 because it will always have the same bits. So we are going to apply the same logic. Let's say 0 XOR 1 XOR 2 XOR 3, and let's say I'm taking these numbers now, 3 XOR 1 XOR 0, right? So if you consider, I can cancel out the same numbers. I can cancel out all the numbers. I will get the remaining number, right? It is 2. So that's what we are going to do. Initially we find the XOR of all the numbers from 0 to n, and then we do the XOR of all the elements in the array, and we find the solution in terms of like the answer will be present if we just XOR all the elements. So this will be n plus n. The time complexity will be n to iterate over 0 to n elements, and n will be to iterate over the array. And the space complexity here is big O of 1, or the constant space, because we are not using any additional space. Let's see if we can reduce this even further to n. Let's say for example 0, 1, 2, 3. Basically if you take the sum of all the elements, it will be 6, and if I have sum of these elements, it's 4. So if I can subtract the overall sum minus the sum we got from the array of elements which we have, we will get the missing element. So here let's understand if we can find the sum of the elements from 0 to n in big O of 1, right? Otherwise it will be again n plus n. So it is nothing but n into n plus 1 by 2. This will give us the formula like which will happen in big O of 1 time. So this is the approach. Let's write the code for both the solutions, and the time complexity for this solution is n, 1. N is the time and 1 is the space. So let's write the code first for the XOR solution which we discussed. So initially it will be 0, then we will iterate over nums dot length I plus plus, or let's say for example n is nums dot length. So we have to iterate from 0 till n included for the XOR operation. XOR equal to answer of this particular value. Then we will iterate over num of numbers, and we will do answer equal to answer XOR number. Then we will return the answer, which will have the remaining missing number. Let's try to run this. Let's submit it. Yes, it's successful. And now the time complexity of this solution is n plus n, nothing but big O of n, and the space complexity of this is big O of 1, or the constant space. Okay, let's write the other solution. So we will initially calculate n is equals to nums dot length, and we will calculate the sum. Sum is nothing but n into n plus 1 overall divided by 2. Now for let num of nums, if I just subtract sum minus equal to this particular number, the remaining sum will be the missing number. So let's try to run this, and let's submit it. Right, and this particular solution is again same. Instead of 2 iterations, we are just going to do 1 iteration. So the time complexity is big O of 1 either ways. Space complexity is big O of 1 because we are not using any additional space apart from few variables, that is big O of 1. I hope the solution is clear. Thank you.